This video, we're going to talk about how to rationalize denominators. These problems are like those from 15.4, numbers 49, 51, 55, 59, 61, and 63. Start off with the square root of 7 divided by the square root of 3. It's not going to help me to write this as a fraction inside of a square root like we did last time because 3 does not divide evenly into 7. So we're going to rationalize this denominator by multiplying by the square root of 3 divided by the square root of 3. Gives me the square root of 7 times 3 is the square root of 21 in the numerator. Square root of 3 times square root of 3 is 3 in the denominator. And that's what we want. We want a rational number in the denominator. We want to get rid of the square root in the denominator, and then we simplify the square root in the numerator as needed. So let's go ahead now and look at 4 divided by the square root of 5. We're going to multiply by square root of 5 over square root of 5. It's going to be 4 square roots of 5 over 5. Now let's look at the square root of 5 divided by 32 while inside a big square root sign. We're going to break that down with our property that we talked about in our last video to the square root of 35 divided by the square root of 32. Square root of 32 breaks down a little bit into the square root of 16 times square root of 2. So this is the square root of 5 over 4 times the square root of 2. The square root of 2 is the only irrational part that's left in the denominator. So I need to multiply by square root of 2 over square root of 2. And that's going to leave me a 4 times 2 in the denominator and a square root of 5 times 2 inside the square root sign in the numerator is the square root of 10 divided by 8. I make sure it's clear that the fraction is not inside the square root sign. Right? Let's look now at number 59. Square root of 1 over 20. It's going to be the square root of 1 divided by the square root of 20. Square root of 1 is 1. Square root of 20 is the same as the square root of 4 times the square root of 5. It's 1 over 2 times the square root of 5. So we're going to multiply that by root 5 over root 5. It's going to give us square root of 5 over 2 times 5 is the square root of 5 over 10. Now for one like number 61, the square root of 7 over 6 over 17, excuse me. Square root of 6 over the square root of 17 is our next step. And so we're going to multiply by root 17 over root 17. There are no common factors here. Nothing's going to come out as a perfect square because 6 is a 2 and a 3. 17 is a prime number, so I'm just going to get a big number multiplied together up there. This is going to be a 17 on the bottom, but 6 times 7 is 42. 6 plus 4 is 10. So 102 is what I have inside the square root sign in my numerator, and that can't be broken down anymore. We have a 17 in our denominator. All right, let's look at this last problem in this section. Square root of 2 over 63. That's going to be a root 2 over root 63 is going to be square root of 9 times square root of 7 is root 2 over 3 root 7. So I need to multiply by root 7 over root 7 is root 14 over 3 times 7 is root 14 over 21. There you go. That's how we're going to rationalize denominators. Next time we'll come back and we'll rationalize some denominators that are not just monomials in the denominators, they have plus or minus signs. We'll have to rationalize using something called the conjugate pair. So we'll talk about that in our next video. See you for the next video.